Hello students, welcome to this class. And here we are going to look at unit number 7, where we are going to look at programming languages and programming process. So the objectives of this unit are going to be to understand the basics of programming and programming languages, explore generations of programming languages and types, understand the criteria of good programming language design. Then we'll also explain the levels of language in computer programming, discuss various language translators or processors, then learn the web programming and related languages, then understand the software development lifecycle of or SDLC of programming. So what is programming? So computer programming, uh, most people call it coding, is the process of designing, writing, testing, debugging, troubleshooting, and maintaining the source code of computer programs. So this so-called source code is written in a programming language. So the purpose of programming is to create a program that exhibits exact desired behavior. So the process of writing source code often requires expertise in many different subjects, including knowledge of application domains, specialized algorithms, and formal logic. So why do we program? So programming helps you understand computers. Also, writing a few simple program uh, increases your confidence level in the area of software programming. Also, learning programming lets you find out quickly whether you like programming and whether you have the analytical turn of mind programmers need. So what are those programming languages? There are different programming languages, for example, Java, Python, COBOL. There are very many. So what are these programming languages? So basically, uh, a programming language is a set of rules that provide a way uh, of telling a computer what operations to perform is what we call a programming language. So whatever you see, the programs, the robots, they're all programmed to perform specific tasks. Okay, so through programming language, you can command the computer on what to do. So there is not, however, just one programming language. There are many, as I have said. So in this chapter, we will learn about controlling a computer through the process of programming. Then let us look at the characteristics of programming languages. So first, a programming language must be simple. It must be easy to learn and use. It should have good readability and should be human recognizable. Also, abstraction is a must-have characteristic for a programming language, in which this is the ability to define the complex structure, and then its degree of usability comes. Then another characteristic is that a computer programming language should be portable. Then programming languages efficiency must be high so that it can be easily converted into a machine code and executed. uh, cons- uh, Consumes little space in memory. Then a programming language should be well structured and documented so that it is suitable for application development. So whatever you do, every level of programming you reach, you have to keep on documenting. Then a programming language should provide a single environment known as integrated uh, development. So we have looked at programming, we have defined programming. So who are the people that program? So these are called programmers. So programmer's job is to convert is convert problem solutions into instructions for the computer. So that is the programmer prepares the instruction of a computer program and runs those instructions on the computer, test the program to see if it is working properly and makes corrections to the program. So the programmer also writes a report on the program depending on what solution is solving. Then these activities are all done for the purpose of helping a user fill a need such as paying employees, billing customers, or admitting students to a college. So let us look at different types of programming languages. So additionally, we also have programming languages called Fortran or form translation. So Fortran was developed way back in 1950s by IBM. So for this language, it was these type of languages were developed or designed for scientific and mathematical applications by scientists and engineers. So we also have uh, OP or object-oriented programming languages. These are based on object-oriented programming approach. They use classes and objects. So these include Java, C++, and others. So we also have what we call special programming languages. So these are scripting languages, command languages, text processing languages, HTML, extensible markup languages. So those are what we call special programming languages. So let us look at criteria in good language design. So we have generality. So this means this avoids special cases in availability or use of constructs, and by combining closely related constructs into a single or more general one. Then we have uniformity. So for the case of uniformity, is all about quality of a language that is similar, or that similar features should look similar and behave similar. Then for extensibility, provide some general mechanism for the user to add new constructs to a language. Then we have implementability, whereby this provides a translator to interpret to interpreter that can be written. So this can address to a complexity of the language definition. Then these are levels of language in computer programming. We have machine language, we have assembly languages, we have high-level languages, very high-level languages, and natural languages. So these are levels of language in programming. So let us look at language processor. So the first language processor we have is a compiler. Okay, so language processor. This is a language processor that reads the complete source program written in high-level language as a whole in one go, and translates it into an equivalent program in machine language. So we also have an assembler. So an assembler is a program used for converting instructions written in low-level assembly code into relocatable machine code. So we also have what we call an interpreter. So the translation of a single statement of source program into machine code is done by a language processor and executes it immediately before moving on to the next line is what we call the interpreter. So example, we have Perl, Python, and MATLAB. Okay. So then we have the World Wide Web development languages, which include uh, HTML, CSS, JavaScript. So these languages uh, are basically used to create web pages in the world of web development or websites. So we have HTML. So the primary use of HTML is to define the content of a web page. Then we have CSS. For CSS is used to specify the layout of the web page, how the web page. So basically, CSS is used to specify the layout of a web page. So how will the web page look like? How will the content be aligned on the web page? So we also have JavaScript. So for JavaScript is a program used to change the behavior of a web page. Okay, it can be dynamic, so it helps that kind of features to be appearing on the web page. So let us look at the most important concept in programming, which is software development life cycle. So these are the processes through which the development goes through. Once you develop a software, you have to go through this kind of life cycle. So software development life cycle is referred to as an application development life cycle that defines a systematic process for building software that ensures the quality and correctness of the software built. So SDLC process aims to produce high quality software that meets customers' expectations. So the system development should be complete in predefined time frame and cost. So it consists a number of processes, and this is its life cycle, starting from requirement analysis. So requirement analysis is always about getting the essential requirements from the customer. And then we have feasibility study. So feasibility study define and document software needs. Then we have design. So here in design is where software design documents are prepared as per the requirement specification document. So once the design is done, so that's where coding comes into play. So in this phase, developers start building the entire system by writing code using the chosen programming language. So once the system has the coding is done, then the system is put into the testing environment uh, by the testing team to test the functionality of the entire system. Then we have uh, installation and deployment. So once the software testing phase is over and no bugs or errors left in the system, then the final uh, process is deploying the system. So based on the feedback given by the project manager, then the software is released and checked for deployment issues if there are any. Then we have the last phase, which is maintenance. So this is where the customer start using the developed system, and the follow-up activities come into play, like bug fixing, upgrade, and enhancing. So that was all for now. Thank you.